Hello y'all, and welcome to a Sky Blue Simulations instructional video. I'm Sky Blue, aka Drew. For this video we will focus on setting up the A320 series FMGS for departure and arrival. This video is made for a virtual airline called Sputnik Virtual, which I am a part of. For this we will be using the XP11 simulator and the towless Airbus A321. Again, a disclaimer, do not attempt to use this video as reference for any real-world application. Consult your company SOPs and FCOMs for proper guidance on the operation of the said topic in this video. Without further ado, let's get in the cockpit and get started. Before we get started, make sure you have your routing, which you may have written down or printed out or typed out. You may find this in the operational flight plan or OFP generated by SimBrief. As so. The routing is usually on the second page, under routing. So for this flight, we're coming from Subic, going to Davao. Now, if ATC gives you a new routing via text or voice, then you use the route given by ATC. I recommend using a plugin called SimBrief Helper to help you fill out your FMGS. It is a very convenient plugin on Explain.org. As you can see, it links to your SimBrief. You can fetch the data. It will get the relevant info for your latest flight. So that's aircraft, airports, and most importantly, the routing. Make sure that your navigational display is set to plan and at a comfortable range like range 20 or range 40. And make sure that your constraints button is set on. This allows you to easily fill up the flight plan, know where the waypoints are located, and know the altitude and speed constraints, especially for your SIDs or stars. For departure, setting up the MCDU is best remembered by using the mnemonic DIFSRIPP. D for data, I for init A, F for flight plan, S for secondary flight plan, R for radnav, I for init B. So you press init and next page, and then the first P is PERF, second is PROG. So again, D, I, F, S, R, I, P, and another P. When the aircraft starts up, you are greeted with the data page. The data page contains your aircraft type, engine type, and your current AirX cycle. Especially the aircraft type is important to know that you boarded the correct aircraft, especially if you're in a fleet that has the same aircraft model but different engine types, or the same Airbus A320 family types. The next is init A. For init A, the first thing you fill out is your destination and origin, RPLB/RPMD. Our alternate for today is Romeo Papa Mike Romeo. That's Gensan. The flight number, you should use the ICAO code for your airline and not the IATA 2-letter code. This is what you see on ATC on websites like Flight Radar. This is what they see, that you are this call sign. For the cost index, you enter it as supplied by your OFP. The cost index is a number between 0 and 99, and it depends per company or maybe per route. Basically, the higher you go, the faster you fly, but the more fuel you spend. Our OFP suggests a cost index of 5. Again, this varies with the company or the routing. Cruising level. Our cruising level final is 35,000 feet. You only put 350. Top of climb temperature, it's also supplied here. Top of climb temperature is -43. We work on the right side. We align the IRS. We now put the climb winds. So putting the climb winds are important to guarantee an accurate ETA, speed calculation, and estimated fuel on board calculation. You may find these on your OFP. Go below your flight logs. You will see your wind information. I usually supply the flight levels from the climb category. So we start here, 110 at 18. Now, the limitation on TOLIS is you need to enter the altitudes in thousands. So if it's flight level, you need to enter it as 1,000 and not as flight level. So this becomes 10,000 or 10,000, like so. And there we go. So we enter the winds until it fills up to flight level 350. We're done with the climb winds page. Next, we enter the tropopause. Basically, the tropopause is the point at which weather stops forming. To put it simply, the temperature change above the tropopause becomes significantly less. You will see the tropopause on your flight log under TRP. So I would put the first one here, 562, that's 56,200 feet. The next is flight plan. So I'll pop this up. We'll put the SimBrief helper here so that we can see what's going on. So again, your routing is going to be from Subic, departure, runway 07, from the ISMA 1 hotel departure. If there is a transition here, insert a transition. For us, it's Bagak. And insert. Cross-check with the charts with regards to constraints and the waypoints themselves. We have Vince, Wilma, ISMA, Xerix. To move the waypoints and center it on the ND, press the up arrow. And then you cross-check with your charts. Vince, Wilma, max 210 knots. ISMA, Xerix, Santo, Bagak. Next, we'll put the en route waypoints. If you see DCT here, that means direct. It is not part of the airway. You may insert this onto a flight plan discontinuity. If one or more navaids exists with the same name, check the frequency, check the distance as well, and you might have to check the latitude and longitude as well. We know that Manila VOR is 114.4, so we choose this. Another direct, it's Apata. Also, to cross-check that you've chosen the right navaid, scroll. So now you know that Manila is just nearby, and then Ipata. Next, we'll learn how to put airways. From Ipata, it's going to be Bravo 462 to Masba, Whiskey 9 Alpha, Bravo November, Whiskey 9 Tremor. To do this, you click on the waypoint lateral revision before the discontinuity. That's Apata. Go to Airways. Via. So from Apata it says Bravo 462. We'll put B462. Now, look at the next airway. It's Whiskey 9 Alpha, so we put that there instead. On the next. Note that the flight plan sequenced itself properly by ending Bravo 462 at Masba. From Whiskey 9 Alpha, goes to Whiskey 9, and then to Rimar. Since it is the last waypoint before the star, there is no more airway, you need to put the waypoint itself in the 2 field. Insert. So you scroll again and check there's no discontinuities except for the last waypoint and your destination. So you can click here on RPMD or here on the destination instead for your arrival. Your arrival will be choosing the correct runway first. For us, it's going to be RNAV 05. Our arrival is the Rimar 2 Romeo. And according to our Navigraph, we will come in from RPAS. From RPAS, then we can do the RNAV approach. Alright. So now go until you see a colored blue RPMD. This is your alternate flight plan. We want to fill this up because we also want an accurate fuel consumption or fuel calculation prediction in case we need to divert to Davao. So your alternate flight plan is found in your OFP yet again. It is on the first part on the second page. Alternate route 2, RPMR 17. This is Megom 1 Alpha, Megom 5 Romeo. So let's do this. Departure, runway 05, Megom 1 Alpha, no transitions, insert, Megom, RPMR, arrival, I believe it's the RNAV 17, Megom 5 Romeo, and I'm not sure about the VIA, we'll just put none for now. Okay, that's your flight plan page. Now, if you want, especially for long flights, you can also put the en route winds for each waypoint. To do that, you go to the vertical revision page. So, any button on the right side of the MCDU, say VINs, access wind data. Go to cruise wind. That's your next phase. So your cruise wind at Masba. So look at your cruise winds. Again, go back to your OFP. And look for the flight log. For the flight log, you can see the wind component here. For example, at Masba, the wind will be 060 degrees at 020 knots. Alternately, if you want a more compact view, go on down to wind information and you can see the winds per waypoint per flight level. For this one, Masba 059 at 020 at 35,000 feet, or flight level 350. So how do we affect that? Again, Masba is 059 at 020. This is especially significant on long flights where you need an accurate calculation, especially with the strong headwinds or tailwinds, to know if you have too much or too little fuel to get your destination. Next, you repeat until you get to the last waypoint shown on the MCDU. So for Lario, for example, 080 at 11. The last waypoint we have is Cowit, 074 at 7. How do we know that it's the last waypoint? There is no more down arrow, which means you can't scroll anymore. So you do need to go to the next phase, which is the descent wind. Preferably, I would do this before our top of descent, rather, during the arrival preparations. So that's your whole flight plan page. Next, we'll get into the secondary flight plan. For the secondary flight plan, you copy active. And there are three things that you could put here on the flight plan. Number one, you could put the alternate runway. This could be a parallel runway or the opposing runway. Say Subic runway 7, you know that there is a possibility of a runway change. You can put runway 25. Another one you can put here is you can put a new destination in case you have to divert from takeoff. Usually this is done if your departure airport is not a good diversion airport, most commonly due to really bad weather. Or let's say the airport will close after you depart, so that necessitates going into another airport which is open 24 hours, like Manila. So for example, I would put RPLL on the destination. Now let's say Subic is still a good destination in case you have to divert on takeoff. Then the first waypoint after Subic, I would press the lateral revision page to the left side. On new destination, I would put RPLB, new destination. For my arrival, I would also go to the arrivals page of Subic, and I would choose an appropriate approach. For me, the most appropriate approach, considering the terrain and compared to the other approach procedures which have you go around the mountains, this is the best for me. All you have to do is hold over the Subic VOR and then do a letdown procedure for the VOR Yankee runway runway 07. And that's what we'll put, the VOR 07 Yankee, approach via Subic. We'll insert that. On the secondary flight plan, again, get the secondary PERF page and go over to approach. So the purpose of the secondary flight plan and PERF page is when you activate the secondary, you don't have to spend time putting in the QNH, the temperature, the winds, and the MDA. So for Subic, the QNH here, according to some brief helper, it's QNH 1013. First we need to put it's 1013, it is. So now we put 1013. Temperature, it says temperature is 29er. And the wind is 070 at 10. VOR runway 07, we go back to the charts, we look at the MDA. The MDA is the minimum descent altitude at which you can continue or abort your landing once you reach the missed approach point. So whenever it's MDA, you add a plus 50, it becomes 750. You do this so that your aircraft has a buffer in case you have to do a go around. It has to take time to generate thrust while it's descending to go around, to start climbing again. So at this point, we'll put 750 on the MDA. Alright, so that's your secondary. The next we're going to do is RadNav. For RadNav, it depends on what you'll be doing on departure. For example, if we chose a conventional departure, let's pick one here. Say we're going to Exora. So then I would put Subic Bay, Sierra Bravo Alpha, and radial 205 on at least my side, VOR 1. Or if that doesn't work out for you, you might also opt to put the VOR Yankee runway 07 I would put the holding course, which is 190, and maybe on the other one I would put the final course of 040. We'll do this instead, the VOR. The Eisman 1 Hotel does not use any nav aids, especially the VOR. So I will decide to put SBA in course 040 on my side, and maybe on the other side I would put Sierra Bravo Alpha 190. Let's do that right now. So even though it is auto-tuned to Sierra Bravo Alpha, it's still a good practice to hard tune. Why? Because in other airports, there are multiple VORs, and you want to be using the correct one. Especially when the SID is full of VOR departures, especially when you're using more than 2 VORs. And that's your RADNAV. Next, we go to INIT B. Click INIT and Next. First off, ensure that you have the correct final reserve fuel for the country you're flying. In the US, it's usually a 45-minute final reserve. So if you need to change this /45, for example, it will give you a final reserve of 45 minutes. Anyway, we'll see how significant that is once we put in our information. So 0 fuel weight and 0 fuel weight CG and block fuel are the most important ones here. You can see them on your ISCS. You need to ensure that you have the correct passenger amount loaded. That's 208. Cargo is 300. The ZFW is 68.9. It's 68.9 here as well. The block fuel is 8,700. We have 8,660 since we've been on the ground for a while. So 68.9 / 28. Block fuel is 8.6. I would choose 8.6 rather than 8.7 since it only needs 2 digits. So we just need to round down. We don't want to be miscalculating our fuel by saying we have 8.7 tons or 8,700 kilograms when in reality we're 40 kilograms short. So here in the Philippines, the final reserve fuel is 30 minutes /30. And that affects our extra time. The next we'll do is PERF page. So of importance, we'll do takeoff page. The first thing you should put is takeoff shift. This is essential when you're doing an intersection departure. The reason for intersection departure might be because it's faster to take off from there due to a shorter taxi, or as in the case in Manila runway 06, there is a taxiway construction or renovation in progress. For training purposes, let's assume that Subic is doing intersection departures. Let's say, since runway 07 is in use, let's say they're doing intersection departures from Echo 1. Now usually, the takeoff runway available length is written down here on additional runway information, especially on the big European airports. Subic does not have these. So you might have to ask Tower or look at NOTAMs to see what the takeoff run available is. If not, just measure it. See here that Jeppesen has a distance ruler. So you can put your fingers here from runway 07 to Echo 1 and then just compare it here to meters. I'm looking at a 1,100 meter shift. So the reason for this shift, why we put it in the MCDU, is so that the aircraft position updates itself once we start our takeoff roll. We don't want to be off by, say, 1 kilometer because we did not update the takeoff shift, especially when we're doing a very accurate and precise RMP departure. So why do we do this? 1,100. So you'll see the effect. Why don't we do this? Config 1, config 2. So look at the V speeds, 142, 143, 146, and flex 41. Now if you put the shift here, these values will change. No flex, which means toga, packs off, V1, 126, 138, and 142. Again, that is also the secondary function of the takeoff shift in TOLIS. In TOLIS. The primary function, which is the real world function, is to update the aircraft position when departing from an intersection. So let's do a full length takeoff. 142, 142, correction 143, and 146. Our flaps will be 2, and then down 0.1, DN 0.1. Our flex temperature is 41. Now, what do we put on the thrust reduction and acceleration altitudes? If the airport has a local noise abatement procedure, we follow that. For example, in Manila, departure procedures for all runways. This is chart 10-4, 1 October 21. This can be found in the Manila reference page or in some other airports in the taxi pages, usually in the airport briefing pages. For this Manila specific procedure, climb thrust shall be selected at 1,500 AGL, above ground level. So that means your thrust reduction altitude. For jet aircraft, a speed of V2 plus 10 knots shall be maintained up to 3,000 above ground level after takeoff, after which acceleration to flap retraction may be commenced. This is your acceleration altitude. So in Manila, note how it says AGL or above ground level. This means that you should look at the airport elevation of Manila. Let's check chart 10-9. The airport elevation is 75, rounded up to the nearest zero, it becomes 80 or 80. Now, let's say we were in Manila. What would we put here? It's the reduction altitude plus the airport elevation. So it'll be 1580. The acceleration is plus 3000, so that becomes /3080. Your engine out acceleration altitude, usually this is a company procedure, or if your company is an EOSID procedure. Going back to thrust reduction acceleration altitude, what if the airport doesn't have a published noise abatement procedure? So check the charts, and if the runway heading and the on-course heading is less than 75 degrees, let's say you're departing runway heading 070 and your on-course will be 100, that's a slight right turn, you would just do plus 800 reduction plus 800 acceleration, so that's 860/860. But what if it was more than 75 degrees? So that's what we're going to be doing from the ISMA 1 hotel departure. It's basically a U-turn to course of 222. So we'll be doing the company standard of 860 and 3060 for reduction and acceleration altitude respectively. Let's put that in there. 860/3060. Alright, that's your perf page for takeoff. Now, go to your climb page. If ATC cleared you to a specific speed, to make you climb at a specific speed after departure, you would put it here on the pre-selected field. So let's say 230, you'd put it there. Another way you could do this is you could put the green dot speed in case of departing in environments where the terrain is going to be an issue, close-in terrain or close-in altitude constraints. Say there's a constraint at Vince and you need to meet it, you can opt for a slower speed, a green dot speed. You could also set your cruise here as well. You can put either speed in 3 digits or your Mach in decimal and then 2 digits. This will override what your cost index has given you. So let's say Mach decimal 80, pre-selected. That's not econ speed anymore. And of course, this will become selected speed once you cruise. However, you can go back to manage mode as suggested with your cost index and your econ. That's your... Last but not very least, we have the PROG page. For the PROG page, I prefer to set this bearing distance to the runway threshold so that we have an accurate position report. More importantly, if this were an RNP authorization required departure, if it says that the procedure requires a specific RNP, that's what you would put here, required. So let's just say that our RNP today requires 0.3. We put 0.3 here, and you check it against the estimated. Of course, if the estimated is lower than the required, then the accuracy is high. If the required is lower than the estimated, the accuracy is low. And that's it. That's your PROG. From now, we'll be doing our departure procedures, and we'll see you in this step. Hello guys, welcome back. We've just reached our top of climb. While there are no flows that you're going to be doing, it's best to think ahead of your aircraft. At this point, check your arrival charts for the first restriction on the star, and you need to make sure that it's there on your flight plan page. So how do we do this? Let's go check our charts. Our expected chart for Davao, the Remar 2 Romeo RNP arrival. If we're coming from Remar, it goes to Eliza and then to Clafu. Clafu has a speed restriction of at or above 6,500. Knowing that, we need to look for it in the flight plan and check if the altitude constraint is there indeed. Let's go and check it out. So we go to flight plan, we keep scrolling until we find Clafu. And see, if it does not have the magenta star, it means that there is no constraint here. So we'll go ahead and get the vertical revision page for Clafu. We'll put it to 6,500 plus. That's 6,500 at or above. And we insert that. Now, let's say ATC wants us to be Clafu at or below 6,500 for whatever odd reason. So what we have to do now is put 6,500 minus, and you insert that. Of course, this is significant in such a way that it might affect your top of descent. In this case, our top of descent happens at 0456 Zulu. Now let's say we do our original restriction of 6,500 plus. (0457), so that means we descend 1 minute later. Next that I want to show you is on some charts. For example, on the Los Angeles chart, the Angel 4 RNAV arrival, there are speed restrictions like these. Turbojet aircraft will have to descend via Mach number until intercepting 280 knots, maintain 280 knots until slowed by the star. Means that before you reach a waypoint with a speed limit, you need to descend via Mach number and then 280 knots after descending on the Mach number. So let's say we were here in Los Angeles. How would we do this? We would look at our PERF descent page. We go to PERF, we go to next phase, we go to descent, and see how this is managed. That means we'll be descending at Mach 0.75 or 0.75 / 286. So that means after 0.75, we'll be transitioning to 286 knots. Now, the instructions say descend via Mach number until mating to 80. So we do /280 and put this in. That's that simple. So again, these are not required flows, but these are really good tools or procedures for planning your descent, especially the altitude constraint. That's the most important one for me. We'll see you again just before we hit our top of descent, or before we get to our top of descent. Alright y'all, welcome back. So right now we're about 20 minutes until top of descent. I think it's a good time for us to prepare for the arrival. So first off, you need to hand over the controls to your pilot monitoring. Mach, Alt Cruise, Nav, AP2 and FD2 auto thrust, maintaining level 350. You have controls. I have controls. For the arrival flow, also known as the top hat or the Mexican hat arrival flow for the FMGS, again, we have already passed our controls to the pilot monitoring. It consists of the following, and when we do this, it's like we're drawing a hat. We start with flight plan, RadNav, PROG, PERF, fuel prediction, and secondary flight plan. And it looks like we just drew a hat, hence the name top hat or Mexican hat flow. We'll start with flight plan. I would prefer to do the descent winds first. I would go to vertical revision, that's any right side key, access wind data, go to next phase, and put in the descent winds. Again, our descent winds are found in our OFP. So I would insert everything under descent from level 350 to 10,000. So level 350 is 113 at 015, 310 is 116 at 014, 200 083 at 018, level 150, 052, 013, and 10,000, 042 to 009. Let's put these into our MCDU, shall we? And we're done. That's our descent winds according to the OFP. The next that we'll do is cross-checking the arrival that's loaded in the flight plan page with your star arrival charts. We have to take note of the waypoint sequencing as well as any altitude and speed constraints. So first we go to charts. We're expecting the Remar to Romeo RNP arrival into Davao. So take note, Remar, Eliza, Clafu at or above 6,500, Wico at or above 5,500 to RPass at or above 4,000. We check this in our aircraft. Of course, we scroll down. So Remar, Eliza, Clafu at or above 6,500, Wico at or above 5,500, and RPass at or above 4,000. Everything looks good with regards to sequencing and altitude and speed constraints. We then check our approach chart. Again, we're expecting the RNP runway 05 from RPass at or above 4,000 to Mike Delta 05 Yankee, and then Mike Delta 05 Foxtrot. Let's see if it's there. RPAS, Mike Delta 05 Yankee, Mike Delta 05 Foxtrot, and then RPMD 05. Everything is looking good. We then also check the missed approach. It's in blue. Missed approach. Climb course 050 to 3000, turn right direct to lowest, and the holder is instructed by ATC. Don't turn before the missed approach point. Don't exceed 230 knots until lowest. And as you can see, we do have lowest, a hold over lowest, and a flight plan. Then of course this is your alternate flight plan, which goes to the alternate airport that you've set. In this case, it's General Santos. That's our flight plan. Next, we'll be looking at the RadNav page. You need to use this page as required. For example, if a star uses one or more VOR nav aids, you may tune those nav aids there as required. Let's look at the chart, another chart here in Davao, one of the old arrivals here. For example, you're coming from Ramar on the Ramar 1 arrival. You would be tuning into Delta, Alpha, Oscar, or Davao VOR, and you would be tuning in to a course of 175 inbound, or a course of radial 355 inbound. It's the same thing, 175 inbound course. Now there are some airports around the world that use 2 or more VORs, so again you'll need to set it to your RadNav as needed. For our case, since we're doing an RNP arrival, I would rather use this on the VOR approach for runway 05. It's a good backup, just in case we lose RNAV or RNP capability. So again, we have Davao VOR 112.1 or just Delta Alpha Oscar, and we'll put the final approach course of 050. Let's put that in there. Delta Alpha Oscar 112.1, it's confirmed. Course is 050. Alright. On the other side, you can put anything else. In Davao, you could have put the same thing, or you can put the misapproach, the holding course. And that's a RadNav. The next we want to put is PROG. For PROG, I prefer putting in the airport and the runway. So, for example, RPMB 05 gives us a good bearing and a good distance to the runway threshold. This is especially useful when the airport has no DME or any VORs for measuring your distance. You also take a look at the GPS if it's primary and if the accuracy is high. In an RNP approach that specifies a value for required RNP, you can also put their required RNP here. Since our estimated is lower than required, the accuracy is high. If the required is lower than the estimated, then it would be low. So let's say 0.3. Of course it's high, but let's say it's 0.01. Well, you can't do that, of course. Just 2.0. Anyway, we'll put 0.3. There we go. So the accuracy is still high, and that's all you need to know about your PROG page. Next page will be your PERF. Go over to your descent. Again, on the PERF descent page, if you haven't already, set your descent speed, as we discussed a while ago. This concludes the descent page. Of course, you have to look at your Mach number and your transition to knots. In this case, we will be transiting to 280 knots after descending on Mach number. Part of the PERF page, go to your approach page. At this time, if you haven't already, you need to get the weather information or the ATIS for the airport. So for Davao, winds are 3 50 at 3. Temperature is 26. And I believe the QNH was 1012. Transition level, sometimes it's written on the ATIS. In some countries or in some airports, it depends on the ATC, or it also depends on the temperature. In the Philippines, the transition level is always flight level 130. We go here to our MDA. So again, we consult our approach chart. Our approach chart will be the RNP runway 05. Again, if it does say LNAV, which is just MDA, if it's just MDA in general, you add a plus 50. So 610 becomes 660. Again, we do this for non-precision approaches, or for if it says MDA, so that the aircraft has a buffer. By the time you activate your takeoff go-around power, the aircraft will have enough power to start the missed approach without penetrating below minimums. Now, if it says DA, or decision altitude, then you don't have to add anything there. So for example, if we did the ILS runway 05 into Davao, it would just be 392, and that's what you would put there in the MDA. So why don't we do that right now? Again, the RMP for runway 05 is 610 plus 50, it's 660. So I'll put 660. The DH is only used for ILS Category 2 and Category 3. Basically, all weather operations or low visibility operations. So a good example of this is in Incheon in Seoul, Korea. So Romeo Kilo Sierra India. We won't be discussing that now. This is just good to know that DH is only used for Category 2 and Category 3 auto land most of the time. Landing configuration is either config 3 or config full. Now this depends on your calculated landing distance or the state of the aircraft. If there's a tailwind, it's always config full. You do not want to be config 3, and a tailwind, you do not want to be using up any more landing distance or any more runway as you land. If it's a headwind, yeah, you can do config 3 or config full, but then again, it depends on what you want to do. Let's say the parking is near the end of your taxiway, you can do config 3, but let's say that your only exit taxiway is before your parking, so you might have to do config full. Should you choose to do config 3, you'll know that config 3 is selected because it has the bigger font. When you choose config 3, always remember to put landing flaps 3 GPWS on, or else you get an ECAM warning that you've chosen the wrong flaps. Turned off, this means that the aircraft is expecting you to do flaps full. Turned on, expecting you to do flaps 3. At this time, it's also a good idea to do your low or medium auto brakes depending on your exit or your landing strategy. That concludes our PERF approach page. One more thing. Your go-around page. So again, if the airport has a noise abatement departure procedure, you may want to put your thrust reduction and acceleration again. Now, recall that for on-course turns more than 75 degrees, which is the case here, it's going to be plus 800 plus 3000. The airport elevation here in Davao is 893. We can round that up to 100. 100 plus 800 is 900. And then the acceleration will be 3,100. So 900 and 3,100. The engine acceleration, usually the company decides on this. Or if your company is an EOSID. That's your Next is your fuel prediction. Very quickly, it shows you your touchdown time in Davao, or your destination rather, in UTC time, and your estimated fuel on board. This shows that we'll be arriving at 0523 UTC, that's about 30 minutes from now. Estimated fuel on board is 3.9 tons on arrival, so we'll be losing about 0.5 tons from now. And this is the fuel on board. This is your your final reserve fuel and your final reserve time. This is your extra fuel, 2.2 tons or 58 minutes before you use your final reserve fuel. Last page on the top hat arrival flow is your secondary flight plan. You have to copy the active flight plan, and then you can do a few more things here. For the secondary flight plan, you can either look for another arrival. Let's say you're expecting the ATC to give you, the RNAV 05, but Ankin 1 arrival, you can do that. Or let's say the ATC is expecting you to do the RNAV runway 23. Or rather, the weather forecast may suggest that it could be runway 23. You could do that as well. One thing that you can also do is, let's say in Hong Kong or in Korea, if the airport has parallel runways, you may choose a parallel runway. And it's a good idea. Let's say the runway you're landing on in Seoul had a runway blocked because there's a dog on the runway or an aircraft stalled on the runway. You can easily switch to the next, to your parallel runway, your backup option, just by pressing activate secondary. For this, we'll just be using a backup approach into Davao. It's going to be the VOR runway 05. We'll put no VIA, no trans. For the secondary flight plan, also set the secondary performance page, specifically the approach page. The chart on the VOR runway 05 suggests, or rather indicates, 550 MDA. Since it's MDA, we add plus 50, it becomes 600. 600. So before you're done with the top hat arrival flow for the FMGS, your pilot monitoring should do the same thing and cross-check everything. Once the pilot monitoring is cross-checked, you may initiate your arrival. Alright everyone, that concludes my instructional video, my first ever instructional video here on YouTube. And this is how to prepare the FMGS for departure and arrival. Thanks for watching. I hope you've learned a thing or two on how to prepare for the departure and arrival flows for the A320 series FMGS. Until next time, this is Sky Blue aka Drew for Sputnik Virtual. See ya!